everyone! In this video we're going to talk a little bit about the math library. The math library contains some pre-written math functions, just like the standard input and output library contains some pre-written input and output functions. We're going to start with a look at our most recent practice program. I asked you to write a program that will calculate the volume of a hemisphere. So this is what that might look like. We are given the equation, the volume is 2/3 pi r cubed. Now pi never changes, so I declared that as a constant value. Obviously this doesn't include all the digits of pi because they're infinite. I only included the first 5. We have for variables the radius and the volume. The radius, we had to ask the user for that. I included it as an integer, so we're only allowing whole numbers for the radius. We asked the user for that piece of information and used our scan format function to read a whole number from the keyboard and store that in the radius variable. Then we're able to use our equations. This is 2/3 pi, and r cubed is calculated by multiplying radius by itself 3 times. This is another way to implement real division. If we don't want to do integer division, all we have to do is make sure that one of our values, either the numerator or the denominator, make sure one of those is not an integer. So here's another easy way around it. Instead of doing 2 divided by 3, we can do 2 divided by 3.0. 3.0 is not a whole number, it's a real number. So this ensures that we're doing real division here. So 2/3 times our constant pi times radius cubed, doing radius times radius times radius, gives us our answer, which we then printed to 2 decimal places so that the user could see that result. Now r cubed is not too hard to implement this way. We take radius and we multiply it by itself 3 times. But what if we needed to raise something to, say, 10 or even 24? We would have to multiply that value by itself 10 times or 24 times, when instead we can use a power function. So r cubed is r to the power of 3. We have a power function to raise things to other powers. And that's included in the math library. What I'm showing you guys here is called the function prototype. The prototype provides some key information about the function that we want to use. It starts with the return type, and that is, what will the function produce for us? In this case, it's telling us that the power function produces a double. Just good news for us, because doubles are the most accurate representation of our numbers. So this allows us to get the most accurate result. This gives us the name of the function, which is POW, P-O-W, short for power. And then it tells us what it expects for its parameter list. Inside this set of parentheses, that's called a parameter list. It's telling us that it takes in 2 values, x and y, both of which are doubles, and we'll use that to produce a double answer. So what the power function will do is it will take x and y and return to us the result x raised y, or x to the power of y. So now we can use that instead of radius times radius times radius. First, we have to include the math library. So the same way we include the standard and input-output library, we're going to go to our preprocessor directives and include math.h, which tells the computer to include the math library for us. Now that we've included it, we have access to all of the functions in the math library, and instead of doing radius times radius times radius, we can call the power function, give it radius, and the value we would like to raise it to. So we want radius to the power of 3. So we're going to call the power function and tell it we want radius to the power of 3. And that produces the exact same answer as radius times radius times radius. The math library has some other cool functions too. So here to look at the most common ones. It has a function for determining the absolute value of a number and also the square root of a number. So let's take a couple minutes to experiment with that. We've got our little test program here, which is just a blank space for us to experiment with. Say we do some integer value x that is negative 240. If we were interested in the absolute value, we might have a separate value y, where y is the absolute value of x. So remember, absolute value is just distance from 0. So negative 240 is 240 spaces or integers from 0. If we include the math library and print out the value of y, then we should see positive 240 because x is currently negative 240. We can print those two values to the screen. The absolute value of x, the absolute value of negative 240, is y, which should be positive 240. So this is just a quick look at it working. So I would encourage you to also grab a blank program where you can also experiment with some of these pre-written functions that we have access to. We can do the same thing with the square root. The absolute value function only works on integers, so we're always going to get an integer result. But the square root function and the power function work on real numbers, so we might get a real answer as a result. So we're going to make sure our answer can be stored in a real number. So it's real number or float y. We'll let y take on the value of the square root of x. And then when we print it out, we need to make sure our percent codes match. So we're going to swap this %d for a %f. And take a look at what that looks like. Now, of course, 36 is a perfect square, so our answer could be a whole number. But this also works for things that aren't perfect squares. And it'll give us the decimal value, or the real number value that matches that. Okay, so those are the three most common math functions in the math library. And I want you guys to experiment with that real quick. Write a short function that determines the distance between 2 points. So this uses the distance formula. Ask the users for the x and y values of each point as if they were stored on a Cartesian plane, and store those in the program. Calculate the distance using the distance formula, which is of course right here for you guys to see. And use the math functions that we just learned. We can use the power function to figure out this value raised to, and the square root function to take the square root of this overall value here. And that should give you the distance. So go ahead and work on that. Don't forget to print out the resultant distance for the user to see, and I'll show you my answer on the web course.